Emmanuel, can you hear me? Can you talk, or your microphone is still messed up? Okay. Okay. I'm going to paste the link to the meeting invite, and then the last time I think he was having an issue with this. I'm going to paste the link, and then if he cannot join, I'll just start the team viewer meeting, and then he can join the team viewer one. Okay. So this is the meeting if he wants to join the Google Hangout. But tell him that he can use the old team viewer invite, right? The last one that I sent. I'm going to start that one right now. If he's having an issue. Hello, I think Gandhi joined. Andy, can you speak? Andy, can you hear me? Andy, can you hear me?
Hello.
Hi, Andy. Can you hear me?
Yeah.
Oh,
Hello.
perfect.
Okay. All right. Hey, wait.
uh, cool. Thanks, Emmanuel, for getting this together. Now we have
Yeah.
to figure out where Cyril is, though. I thought he was on, but I can't hear him anymore. But can we send this one to Cyril also? I mean, I've invited him like multiple times, but I'm not getting any response from him. Okay. All right. I mean, we'll start in the next couple of minutes here. All right. I'm gonna send the invite one more time to Cyril, and if he, I think he was on the earlier chat, but okay. All right. Excellent. So, okay. Thank you, Manuel, for that. So hopefully he will join us soon. I mean, this is a late night session, so we don't have a lot of time. But ultimately, this is supposed to be our last session, right, for this intermediate SQL class where we've touched on a lot of topics. Try to brush up on our SQL skills, the ability to write queries, and learned about the architecture of Oracle, and doing sort of doing some performance tuning concepts, and then ultimately try to wrap it up with PL SQL, procedural language SQL. Before I proceed, is there any question? I mean, first of all, I apologize. The last time I couldn't send you any artifacts after the last Saturday's meeting. I had quite a few technical issues after the meeting, and been trying to come up with a format that would work long term. And I really thank you, Andy. I really want to use this Google Hangout setup. I did finally get the video together, so at the end of this, I'll send you today's video as well as Saturday's video. That will just serve as a resource for your reference down the line. How are we doing with getting Cyril on board here? Okay, so does anybody have any question before we proceed?
I was suggesting to Emmanuel, I mean, I don't know if it works for you. And today you said you were going to deal with a project, like start a project,
Yes.
and then so what will be the the format? Because I wish we could have something like the you used to do with the assignment, so that if we we able to, I mean, after the introduction with the project, then maybe we try to put something together individually, and then if we can have one more session where we can also present what we did, just to see how much I mean, we can input, and then if we are in the right direction, if if that works for you.
Yeah, that's not a bad idea.
Mhm.
To just stand. So what you want is um, perhaps have one more session where we would, everybody will get a chance to present on their project, like the assignment. Is that what you're saying?
Correct. That's right. Yeah.
Okay. Um, that's fair. I mean, okay.
I know we'll not be able to do everything, but I mean, even if you're able to tell us, oh yeah, this is directional, you're on the right path. I mean, we can always keep working on it individually. If we have questions, I know we can reach out to you
Right.
for one or two questions. Yeah, but I just wanted to have that feel and then be able to initiate something like that. I mean, by ourselves, and then we keep going with it.
Okay. Yeah, I mean, we would. I'll come up with something by the end of the
Yeah.
session.
All right.
Um, I mean, really, the idea of this session, I wanted to do. We'll touch on some concepts and then do some project, but we're going to do a second session, or at least a final session. Then we'll probably defer some of the project work towards that session. The reason being, I want to get a sense of where people really are in terms of what areas they want us to spend some more time. And if
Okay.
you have any general specific questions, any topics we've covered that you're still not comfortable with, because understandably, the idea of these sessions are just to equip you with the basic fundamentals so that when you pick up the material, you can at least read through it. I'll be honest with you. I mean, Oracle's documentation is millions and millions of pages. If I have to put a percentage to it, I don't think I've even gone through 10% of it after all these
Mhm.
years. And
Yeah.
the reason is that most of the other stuff, like, there's a lot of specialization, right? So beyond a certain point, you may be interested in being a DBA, in which case you focus on the materials that have to do with the architecture of it, the server setup, the configurations, the network infrastructure setup, that piece. Or you can go a route where you're just a pure PLC code developer, right? And then there are those who just write queries. Although it's much more difficult to get jobs as someone who just write SQL, right? You definitely want to go as a PLC code slash SQL developer. But there are cases where you find teams where you just be the SQL developer. Then there are those who are on the ETL side, right? They basically use certain tools with Oracle to pull data from different sources and they load it. So that part of it, that's what we had done a little bit, where you would have a CSV file and then you try to load it into a table. There are ways to write scripts that would do it, but um, you would have to know some more programming, either in Python or Corn shell scripting, in order for you to really kind of do that piece of it. The ETL, instruction translation and load, it goes hand in hand with knowing some scripting language beyond the SQL and knowing the Oracle SQL stuff. So, um, as I said, I certainly can teach you guys some of the other stuff down the line if you're interested. Um, and so, yeah, we can sort of play by ear for those of you who are still interested in other courses to sharpen your skills. Yes, we can certainly do that. Um, Emmanuel, is Cyril going to be able to join? I don't want to. You know what? I think we'll just start. It's time is far spent. So, okay. Andy, do you have a question?
Oh no, that was my question. I mean, that was a suggestion, not a question, actually.
No, that's
So
fine. I mean, I think it's a great
yeah,
suggestion. I mean, Emmanuel and I have spoken quite at length about these classes. I mean, for me, this is, it's been a learning curve for me as well, in
Yeah.
terms of how we will structure these things going down the line. I have learned a lot from you guys, surprisingly. I mean, not surprisingly, it may come as a surprise to you guys that I've learned a lot from you. Um, there are other pieces of this that, quite frankly, you have to just keep practicing and reading and practicing. For somebody like Emmanuel, who's already working actively in this, hopefully you can continue to work on it. I had requested for your resumes, right? It's really Andy and Cyril,
Yeah.
because I want to be able to help you, I guess, tailor it so that you can go for specific jobs. Like I said, Emmanuel is really good at it, but I can also help you if you are interested, because um, I think if you start looking for work in this area, it will push you to keep studying. Otherwise, it will just be another thing that you've studied, and it will just remain as that, and you will lose those skills very quickly. So if you do um, study, and if you do apply for jobs and you go for a couple of interviews, um, that in itself will keep you on your toes. So my strong recommendation is please send me your resumes and let's push it out there. I do have access to a lot of folks who hire for roles, and um, I can definitely, to the extent that I can help, I can definitely push your resume along um, those channels to see if you'll be a match for them.
Okay.
Beyond what I can do, there are so many, of course, job sites out there. Dice is definitely what Emmanuel speaks highly of. Dice and um, Indeed. These are all great resources. However, if you don't tailor your resume very well, you won't get a lot of calls. So that's where that one comes in. Okay. Um, so much said there. What I want to do is to quickly uh, wrap up the POC quote that we had discussed, then go through a few examples, and then introduce a couple of ideas from the previous project and how we can use POC code to enrich it. Okay. We may not be able to do everything within the short time that we have, but I'm willing to accommodate you guys for one more session. And that reminds me, payment is due. So please make necessary arrangements. Then we do our final session this Saturday. And beyond that, anything you guys are interested, for those of you who will be interested in either taking more SQL training or switching to doing at least one scripting language, which I highly recommend you learn one scripting language. Um, then that will be that. So what is I'm presenting this, right? So I need to switch between multiple screens today. All right, switching to there we go. Okay. So can you see the POSQL screen there? Not the Oracle developer.
Yeah, I can see. Yeah, I can see that.
All right.
Yeah.
Now, Emmanuel, you pinged that you need help. So you know what? I'm gonna dial into the bridge, and you should dial in so that I can hear exactly what your help is, because it looks like you still have an issue with your microphone. Emmanuel, you definitely need to get a new laptop. And get a Chromebook for $200. I don't know if it's $200, but
Is it that cheap?
yeah, some of the Chromebooks are really, really cheap.
Yeah.
I mean, I can't believe that these days you can get really good laptops for like 250.
Yeah, that's true.
And when I first came into this country and like spent $1,300 on a laptop that a year and a half later it was
That's
garbage.
so,
I'm sure everybody has a similar story. Emmanuel, I'm on the conference bridge. If you want to dial in, okay. So I want to know what you said you have a question. You need some help or something? The number is 718. 862 598 488. All right. When Emmanuel you join, then that's fine. Right. I'm just gonna put you on mute on the conference bridge so that when you talk, I'll try to paraphrase it so that Andy or whenever Cyril joins, they can also hear what you said. Or at least what your question was. Okay. All right, Andy. Okay, Emmanuel, if you can hear me, I am going to go through the POC code notes. Now, last time we did discuss general programming language structure of a POC code, right? And I talked to you about anonymous POC code block, which is effectively when you write some piece of code which would run some query, get some results, and then look through the results set, and then output some content either to a file or to a user interface. So that was effectively the thrust of it, was to show you how you could use if-else statements, how you can loop through or iterate through a program. And then we finalized it by sort of going through cursors and what implicit cursors and explicit cursors were. Then the last section is where I rushed through, which was basically after you've written a program, if you want to save the program so that you can use it later, then you start giving the programs names. So for example, what's it called? Are you familiar with recording macros in Excel or in any utility, Andy?
Macros in Excel. Yeah, I can do that.
You can record macros, right?
Right, yeah.
So you know how when you record a macro, right, let's say it's an Excel, for example, or a text pad or any of these applications that allow you to record macros, they're really just telling you that you can automate something and give it a name. And then anytime you need to do the same thing, just click that name and it will do it for you, right?
Right.
So when you come to stored PL/SQL blocks, that's all you're saying is that you can give different programs you write names, and then you can reuse them. Okay, so you think of a function, right? When we talk about function, we're used to functions, right? Addition function, subtraction function, trim function, NVL is a function. These are all sort of PL/SQL blocks that have been given names. So when you call in your SQL statement, if you call NVL, for example, behind the scenes, it's actually a function, right? And this name is called NVL, and it takes a parameter The parameter, it takes two parameters actually. It takes the value that you want to check against if it's null, and if it's null, what the default value you want to use, right? And it would execute something like this. The key is that it will have a begin and an end, right? This is where you would do your processing. And as a function, it must always return a value. Most programming languages, and I don't want to say every, but most programming languages, or programming languages that distinguish between two things, subroutines and functions or methods, the functions always return an output. The subroutines don't necessarily do. When we think of a subroutine, we mean a process, some code that will do something. Okay, maybe it will connect to some database, get a list of emails, and send out an email. It doesn't really give you back an output saying, okay, 1 + 1 is equal to 2, for example. So functions always return some value, okay? So here's an example that they're going to show you. Now, this thing is very, very important as you develop SQL, as you write a lot of SQL for your projects. In fact, you join most companies, and if you're doing pure SQL work, you will find yourself writing a lot of functions because typically somebody may have there's some business rule that you would have to implement in a function so that everybody else can use. So here is an example of a function that the name is to date check null, right? That's whatever the name the person gave it. And effectively, you try to give your functions names so that somebody can figure out what you're trying to do there, but it's not a requirement. It's not a requirement. Mostly people try to use names that would make sense. I mean, when I read this, it almost seems like, you're going to convert something to a date and you're going to check if it's null, right? So here's a function, and the user is going to give it a string and a format to use, right? So in effect, and it's going to return a date. It's going to return a date. A PL/SQL always starts with begin and an end, right? So when you have a named PL/SQL, in this case a function, then the end, you actually give the function name here. This is in contrast to when we did the anonymous PL/SQL, the end was followed by a semicolon and a slash, okay? Here, you have an end followed by the function name or whatever procedure name. In this case, you're dealing with a function, the semicolon, and then the slash, okay? So this is a function that the user says, all right, I'm going to look at the date string. Somebody's going to give me a date string. I'm going to check if it's null. If it's null, I'm going to return null. However, if it is not null, I'm going to return to the user whatever date string they gave me and some format, okay? So you may ask yourself, okay, what exactly is this, all right? Now, if you have some programming background, this shouldn't be foreign. But if you don't, I'll try to give you another analogy to think about it. If let's say you're writing a function to add two numbers, right? And this is the first number and this is the second number. All you would say is create a replace function sum. The first argument is, let's say, some number, and the second argument is another number. And then you would say, okay, I'm going to return, instead of a date, in that case, let's say here you return a number type, right? And if you add numbers, instead of varchar 2, you here this will be numbers, right? Instead of varchar 2, because you're adding numbers. And what you would do is you say, if the first argument is null, then return null. So basically, that's why whenever you do 1 + null, you get null, right? Most of these functions like addition and stuff that we do behind the scenes, they actually implement this very initial check. They will check if one of the inputs is null, and as soon as one of the inputs is null, then it's going to return null. It wouldn't even go ahead and even do anything else. The way this part works is like I said, it says if something is null, then return null. As soon as you hit this point, the code executes. It executes and exits. It wouldn't even look at this part of it. It will just exit out of the if block. Okay. Any questions? Yeah, Emmanuel. Oh, you just started hearing me? Okay. Um, okay. Well, all right. So try your best to follow along. We're just reviewing how to create functions in PL/SQL. Okay, so we just discussed how to create functions in PL/SQL. So a function is just a way, you're given a name to a procedure. I mean, not a procedure, a code you've written that you want to reuse, right? And I was using the example of creating a macro. You can Excel, you create a macro, or TextPad, or Notepad++, or any of these applications out there that allows you to create macros. Once you create the macro, you will save it. So the next time you want to run the same macro, just go to the macros section and then you select it and you run it. Behind the scenes, all these programs, they do things like this. In Oracle, if you want to create a function to do something, you give it a name and you list the parameters. Here's a function that takes two parameters. The first parameter is the date string and then the date format. Now, oftentimes in data, you're going to see that a lot of times you're going to get dates in so many formats. Somebody will give you mm-yy, mm/dd/yyyy. Somebody will give you -dd-dd-yyyy or yy. So many different formats that are out there. So you as a developer can actually create a function that would say, hey, give me a date, and as long as you give it to me and you tell me the format that you're supplying it to me, I'm going to convert it into Oracle's date format and store that data so that Oracle stores it consistently. How this works is, from a practical standpoint, if you're working in an organization and you have data from so many different systems, guess what? Different developers wrote it, and different developers will output data in different formats. Sometimes you'll be working in, you have developers in India or in London or different parts of the world, and they may be dealing with dates in different formats. So within your program, you have to find a way to standardize all the dates that you're going to get, right? And at that point, when that happens, it's best to create functions so that you have a function that, would kind of streamline the formatting of your data. So in this function, the very structure of any PL/SQL is there is the begin, and then there's the end, and there's this / here. And I compared it to that in the anonymous PL/SQL. Anonymous PL/SQL being one where there is no name, right? This is something you write and you run it once. You don't have the function name here. You just have the semicolon. Okay. Functions always return a value. Okay. So if you go for an interview, they can actually ask you, what is the difference between a function and a procedure? And the first thing they want to know is that a function returns a value. Okay. That's the first answer they want to get, beyond some of the other stuff that differences that may exist, because the main important difference is that functions return a value. Okay. Procedures, on the other hand, they differ because they don't really return the value to the caller. What that means is you can have a procedure, and they have a pretty, they have an example here. It's not really a very, you know, admittedly, not a very great example, but they try to highlight this point where you can have a procedure that basically, you know, it will connect to some data, run a query, get some results, loop through it, and then once it's done, it probably may print something on the screen, right? Um, what it means by that is that in programming, right, there are two main sort of things that we deal with in terms of operations. You have an operation that can give you an output, like we talk about 1+1, right? At the addition operation, you give it two inputs and it will sum it up and give you an output back to you, the caller. A procedure is one that doesn't really return anything back to you, but procedure is actually very powerful. Procedures themselves, they use functions to do their work, right? So a procedure, when you talk about a procedure is like this big body that will take a whole bunch of functions, use the outputs, and then do, massage it or massage them in some way to achieve some end goal. And an example could be having a program that wakes up every morning and then it will scan the list of all the stocks that are out there in your database, right? Referring to our project. And then it will come back and say, hey, here's a list of stocks that meet a certain criteria, such as, hey, their 21-day moving average just crossed their 50-day moving average as of yesterday's close. And it's just like an email report you get, right? Technically, that's an output, but it's not an output in the traditional sense of in your program saying X plus Y is equal to Z, right? So now the structure of a procedure is really similar to a function. The difference here, and I'm going to try to put this in context, you see that it says create or replace function. Here will be create or replace procedure. The create or replace is very, very important because if, let's say, somebody's already created, it's like if somebody's already created the procedure by the same name that you're trying to use, you may want to be able to replace it, especially in an enterprise system where maybe you go and there's already a procedure or a function that somebody's written and you've been asked to go and replace it, right? There you can say replace procedure, but generally, the structure we use is create or replace to say, hey, if it exists, replace it. If it does not exist, then create it, right? Sort of a one-stop shop. It's interestingly enough, Oracle doesn't really have a very clean way to say create or replace table. It doesn't have that, and it's for security, it's for safety reason because table has a table that has tons of data. If somebody makes the mistake of wiping it out by accident because they did create or replace, that can be a huge headache. But as a developer, sometimes I wish they had this structure of create or replace table, but they don't. Much like the function, the procedure too takes parameters, right? So you can give it a list of parameters, and in each parameter, you can have a decorator for it and say, hey, this is actually an input parameter, or this is an out parameter, or this is an in and out parameter, okay? So these are the three decorators you can give to your input parameter. And then you can also provide default values of your parameters. So, think about a system that sends out emails and you want to say, hey, address, some users should always specify their form email address. However, if they don't, use a default email address of so at yahoo.com, right? That's the default email address the system should use. All right. The general structure is the same. It also begin and an end, right? Here you end with the function name, here you end with the procedure name, okay? So here it is an example that the author here talks about creating a procedure that will get the number of students. The idea of this is that, when you have like, and this is actually a very powerful construction in database design in general is things like this, where it's like a business trade secret, right? I mean, this is not like some major trade secret, but um, you go to any company in the world, right, that is doing something significant, they have tons and tons of procedures that they've written in their databases. And the reason is it's actually a way for you to guard your secret of a business operation. Because you know this sort of stuff, when you write a procedure, is hidden within the database and only authorized users will get to see it, right? So Emmanuel, you probably are familiar with this, where you can have functions or procedures within that you have select access to, but you can never really view the definition of them, right? Somebody will tell you, oh, go and run this and it'll give you some output. But when you try to describe it, it will never show you what is behind the scenes. It's one of the most powerful reasons why we use procedures. Is we use it to encapsulate or hide business logic from users who are not entitled to see it. Okay, so in this particular case, there's some procedure, and this procedure is supposed to get the number of students. And they, you know, the requirement that most likely was given to the person who constructed this was, if I give you a course ID, right? The course ID I give you is an input, IN, and it's always going to be a number type. Okay, so when I call the procedure, I'll give you the course ID, and you're going to use that as an input. And then I'm also going to give you an out, so which is number of students, which is out. And this particular construct, the first time you look at it, is always a little confusing, but it's actually not bad. It's actually a way for when you learn Java or C# or Python or any of these languages. That's actually one way in which you outsource the translation of data from database systems to the other programming languages. They have their own mechanism that connects how data flows between them. So when you specify that is an out, then the calling program has to be responsible of always providing a container in which you're supposed to store whatever output they want. Because typically some of these outputs are like cursors. They're a lot of data, right? And so they have to show you that, okay, I'm going to give you some output, and you have to give me enough memory within your program to store it. You know, like they said here, admittedly, there are better ways to compute the number of students, but this is a good opportunity to show a cursor in action, right? So we learned about cursors from last, this is a named cursor. So it says cursor student care, right? Is select student ID, student name from course, right? Where course ID is this. Now, this is just a SQL statement. We're used to running SQL, right? So he's doing a select from where. So he's selecting the student ID and the student name from a table called course, and where the course ID is equal to this course ID, which is the input the user gave, right? So that cursor, right, once you define it, it doesn't really execute right away, right? But you know that you're going to get a bunch of, you in theory, going to get a bunch of rows that meets this requirement. Because think about it, that in a university, there could be 50 students taking the same course, right? So this, in theory, when you run this query, a SQL developer can come back with 50 rows of data. So you need to figure out or allocate enough memory to process each row, right? So since we are outputting the student ID and the student name, it makes sense to create a student record, allocate memory to handle each student's record. Recall that we talked about within the student care, which is this cursor, you can get its row type, and then you can use that to store the student record. Then you start the meat of your program, begin, end. You're going to do a loop. So your loop says fetch. So the moment you type the fetch is when it actually executes and give you the data. So when it executes, it gets and says, okay, let me fetch the first student into this, right? I fetch, let's say there are 50 students that match this criteria. It will fetch it and say, okay, let me pick the first student in my rows. And it will say, you exit when there are no more data found. So this is actually one of the nice features Oracle PL/SQL gives you, that if you are iterating through or stepping through a number of rows of data, it has this structure not found, which will tell you when you've hit the end of your loop, right? So if you have a cursor of 50 rows and you're looping through the 50 rows, you want to stop as soon as you've hit the last row, right? And the way you know if the last row is when you query the cursor, you say, cursor, do you have any more rows? Then if it says no, then you are exiting, okay? Otherwise, if it has more rows, you say, oh, increment the number of students. So here he's declared, since a number of students are up, this was supplied by the user, you just added one to it. So by the end of this execution, you would have a number of whatever users. Then you end your loop. Very, very importantly with cursors is as soon as you're done with them, you must always close them. Other than that, you can actually crash your database. When I joined maybe I was when I joined, but about 2 years into my first job, our database crashed. We brought these DBAs in, they looked at it, and it turned out there was a program that it was an old program that somebody had written, and they weren't closing their cursors very well. But it's sort of something that people use rarely, and something happened, and a bunch of users started using that thing, and every user was creating a cursor and was never closing that cursor, which meant a lot of memory was being used to store all this data in the database, and the database ran out of memory and it said, I don't have any more space, and it crashed. So please always close your cursors after you're done processing them. Okay? A cursor is nothing but a pointer to a bunch of data. You can think of a cursor as like, I have a table and it has a bunch of rows in them, and I have a pointer to it, right? Once you do select star from that table, that data gets loaded into the RAM, into the memory. So if every user is doing the same thing and you have 100 users and they're all pulling a table with 1 million rows, you'll crash your system very quickly. So that's why when that user is done, you just close that cursor right away. I had mentioned exception block, and exception handling is a very important programming concept. It's not just PL/SQL. It's a concept that spans every single programming language that you can think of. In that we know that programs invariably will crash. Programs invariably would break. So you need to have logic within your program that when the program runs into a bug, it would exit gracefully. I don't know if you guys remember, but when Microsoft, Windows 95, Windows 98, NT, and all those things, they used to have a lot of problems. It would crash a lot when it first came out. And it had to do with mostly, amongst other things, it had to do with exception handling. Because most of the time, the program didn't know if a program somebody was using, like Microsoft Word, for example, and they run into an issue, it just didn't know how to exit very cleanly, right? And because of that, sometimes you can have a system and You go in and you have the user is running Excel. You have like 50 instances of Excel running in the background. You're like, why? Oh, I only have one Excel running. Well, I see 50 in your task manager, right? Because Excel is actually very notorious, even to this day, in terms of how it exits itself. So exception handling is a very important piece because if you do it well, then when a program crashes, it will totally free up resources and give it back to you, give it back to other users of the server. So in Oracle, in PL/SQL, when you do an exception handling, there is one called when others, which is like the global catch-all. Here you're saying if any exception happen, when other exceptions, I don't know why they call it others, but when others happen, then raises, this is a construct that they give you, raise application error. This basically means that the app has failed, right? So you raise this exception, and it's up to the calling program to look out for this code in their program and to handle it, and then to exit out of the program. Now, some of these things, they're a little difficult to understand if you haven't done a lot of programming. So for what it's worth, just, I'm taking pains to go through it so that if you do ever want to learn it, you can at least play back this video, or, maybe you've picked it up already and, you make a very strong impression in an interview if you understand this stuff, okay? Now, last thing here is packages. So we're trying to build this stock trading program, right? When you go to any organization, again, remember that a database, before I go, is there any question? Does anybody have any question? You guys still with me? Emmanuel has a question. But it has it for views, right? Oh, sorry, I didn't see your question, Emmanuel. Are you can you hear me, Emmanuel? Yeah, I can hear you on the phone. You typed that, but it has it for views. What do you mean? Yeah, it's also for views. Yeah, yeah. The create or replace construct directive is also, you can also use it for views. You just cannot use it for table. You can use it for views. You can use it for triggers. You can use it for packages, procedures, functions, but not for table. Okay. Okay, that's a clarity you wanted. Okay. All right. Yes. Andy, basically, Emmanuel was saying that it's create or replace. That we're talking about, can we use it for views as well? And I said yes, but not for table.
Okay.
Okay. Now,
earlier on, I think when you go up a little bit to the functions,
yeah,
you mentioned something. If the caller of the function, what could be the caller of the function?
right. So the call of a function is, well, it would be another program. Emmanuel just said would be another program. It would be another program, but in a very simplistic sense, right? Let me share my SQL developer and just highlight this point. Calling a function is, you can call it in so many places, but typically it's within a certain framework. So let's say, for example, you're writing POC, you're writing a SQL, you can call functions within SQL, right? So let's share for now the
Like we use average in
exactly,
okay,
exactly. In that instance, yes, you are calling the function. That's actually what it is. I mean, yeah, you got it. That's all it is. I'm not even gonna, yeah. You call in the function average, and you're gonna give it. You say, hey, get the average of some values, right? NVL is a function. You say NVL, take the value in the column, check to see if it's null. If it's null, do something. Maybe use 1 or use 0 or whatever, right? You are the caller of the function. and you call in within your program. Procedures, like, and it's so sort of interesting when you first start writing these, like, okay, so what is the real difference between a procedure and yeah, procedures also uses call procedures, but you cannot call a procedure in your query, for example, right? So you can call this function that says to date check null. You can call this within your SQL query that you'll be writing, right? However, you cannot call a procedure, right, within your SQL query, because a procedure does a lot of work, right? A procedure does things that it doesn't really give you an output that you can consume. Let's make it that's probably the best way. It doesn't give you an output that you can easily consume within your SQL code, right? The outputs of procedures typically are not just like yeah, Emmanuel, I lost you. Can you repeat your question? I can hear you now. Yes, please go ahead. Yeah, procedure in a way, it's more of an action than an event. So it's saying that take this action, right? So where the action can be every morning at 8 o'clock, connect to the database, give me the list of all the employees, and if the person was hired more than 5 years ago, right? And if the person just turned 5 years in terms of the hire date, send out an email to them and say, hey, congratulations for working with us for 5 years. You know how like these cell phone companies or like they'll send you all these emails. It's not like they care. It's not like somebody did it. It's just a program that does it. Right? A program that would say, "Hey, thank you for having your credit card with us for the last 10 years." Right? But it's a nice customer relationship kind of thing, right? You get it and you kind of feel good, right? So it's taking an action, yes. Just Andy, Emmanuel was like trying to say one way to think of a procedure is that a procedure takes actions, right, as opposed to a function that will give you an output back. So
Okay.
now to wrap this PLC code thing up is to talk about packages, and I was talking about packages in the context of, let's say you go on, you're given a project. Let's say you start like we were working on a project of stock trading project. Then the first thing you do is you create a package or stock trading project package. And then all the functions and the procedures we write, we'll keep it within that package. It's sort of a way to group our things because within a database system, there will be so many people using it, so many functions, so many procedures. And just for, of course, organization and neatness and sort of good standard practice, anytime you work on a project and you have to create more than, in my opinion, anytime you have a project, create a package for that project, right? So, whatever it is, whether big or small, just create a package for it. Because down the line, as it gets bigger and bigger and bigger, okay, and so many people are using the system, you find out that there's just so much stuff sitting all over the place, and it's so difficult to keep track of it. So Oracle gives you packages as a construct that allows you to put your functions and procedure into a larger unit, right? Some people will call like you have a library of functions or utilities that belongs to a common project, right? And as a package, what you do when you're creating a package is you first create what they call a spec. The spec is basically saying within this package, I have the following things. So it's almost like a manifest, right? Saying that, okay, I am working on this stock trading project, and I've created the following 10 functions and 20 procedures. So that in the package spec, it's just a matter of just saying I have function this, I have procedure this, you don't, the details is never here. This is just the um I mean, sometimes you'll call this like yeah, and the manifest is probably the best way for me to describe this, because you're basically saying you're publicizing what you can do, but you're not showing anybody how you actually do it. Is within the body itself, the package body, right? So you see, the first part is you create a replace package. But after you've done this, then you go ahead and say create replace package body. What is the actual thing that is doing? And so you pick this to date function, and then you explain exactly what you're doing and how you write a code to do it. You pick this get number of students, then you actually get the details and you put it there. And once it's all said and done, everything will be in one big umbrella, right? This approach is very, very common. It's a very common pattern in design. They call it modular design in some systems, where you put these modules or similar components within one umbrella, right? It's very common across. You see it in Python, you see it in Java, C Sharp, all these languages. They all kind of do similar things, because the idea behind it is not unique to pure SQL, right? It's just sort of unique to just general organizations or principles of organization, right? Um, yeah, so they have some of these terminologies here. One of which is, in addition to performing the function of being a common library of procedures and functions, there are three aspects of Oracle packages that are unique. The one is the initialization section, right? The initialization is executed only once, right? As soon as you start the session. So it's almost like when you connect to a website, right? The very first person who connects to Facebook in the morning probably gets all this. Actually, that's probably a bad example, but think of it like you're within your organization, and you have some website, and it goes down. The first person who goes to the website in the beginning is very slow, because everything starts from scratch. Nothing is cached. As the previous guys will experience faster response times, because all the initialization data has been preloaded, right? In fact, a very common example is when you go to Oracle SQL Developer and you write a query, select star from employees. If, let's say, you start SQL Developer first, okay, and you do select star from employees, it may take you maybe half a second. If you highlight the query you run again, now it will take you 0.001 second. Why? Because the very first time you ran select star from employees, right, after bringing up SQL Developer, it actually went in and did the hard work of actually reading the data from hard disk and actually displaying it to you. The subsequent submissions would actually read a copy of the data which is in the RAM, right? So then it's very fast, okay? So when you talk about packages and initialization sections only executed once, it's actually a very useful feature, because if you have a package and you have a bunch of stuff within that package, it's nice that the very first time somebody calls it, it would initialize it, and all the subsequent users would. There's no need to do that, right? Packages by default, they return the values of variables within a session after execution within the package, execution of a procedure or function within the package, right? So what that means is, if I call a procedure that will send an email, right, to tell everybody who spent more than who just turned 5 years as an employee, right, it's done. It does not mean that the next person that brings it up, is going to know that somebody's already run that, right? So it's almost like you have this atomic operation, which is say, I've done it and I'm gone. If you do it again, I'll give you the same output or the same set of behavior or action that you did, right? In some systems, you don't want that, right? In some systems, you want to know that after I've finished, I need to know where I left off. And then the next time somebody calls it, it will continue from where you left off, okay? As opposed to always starting from the beginning, okay? Packages can be overloaded. package can contain multiple procedures and functions with the same name, provided the parameters passed in and numbers are different. This is a very nice feature or a very useful construct, which is, imagine that you have a function that says function to date check null. Right now, its signature, which is what makes it unique, is that the name and the parameters that it has. I could actually create another function that's called today check null, which just takes one parameter, or which takes 3 or 10 parameters. And it will still allow me to use the same function name, meaning it allows me to override the function. I can create functions that have the same name, except that the parameter will be different. Right? And that's actually useful, especially when you have a system. Let's say you go in and you have a system and it's working fine, and somebody comes in and says, hey, there's a problem here, but your question is, oh, well, if I go and change this, it's going to, so many people are using this function. If I change it, it's going to I don't have, who's going to test all these systems that are using this function, right? And you go to big organizations, that's always a huge problem, because somebody's reading code 10 years ago and it's working. And if somebody finds out it doesn't work for me, oh, we all have a common function that gives us the interest rate to charge. But then there's this new regulatory requirement, and I'm trying to satisfy that when I go and get the interest, it's slightly off. And so I cannot use it in my thing. Oh man, well, we cannot go and change it, because if we change it for you, it may break everybody else's. So we can't do that. What we can do is we allow you to create we will clone the function, and then we just give it one extra parameter or one less parameter, so that it's the same name as the one you're using, but you just give it one extra parameter or one less parameter, and it will give you the specific code that works for your regulatory requirement, right? In fact, in a lot of systems, enterprise systems, that pattern is very, very, very important to have, because you never want to change a component that has been there, tried and tested, just because somebody calls you and say, hey, this thing is not working, and you're like, oh, I can go and change it. You need to do what they call regression testing, right? If you're going to change any component in any system, right, you need to make sure that all the dependencies are checked. So if you don't want to go through that headache, then you just say, hey, you know what? I can overload the package, or I can overload the function. So let me just create another one with the same name, but this time it will have an extra parameter that would handle this particular scenario, right? So finally, we talk about these exceptions, right? So if you look at the procedure here, where we look at exceptions, when I sort of joked that when others then, right? This is saying if any other exception happens, do this. It's as opposed to, typically, Oracle gives you a bunch of pre-packaged exception names that you can use, and it will fit your particular situation. So if, let's say you've written a query and you run it and no data is found, right? It can give you the no data found exception, so that you say, hey, I was supposed to have gotten the name of an employee. Somebody called my function, my procedure, and the procedure is supposed to go and get the employee and then do something. But when I called, I didn't get any employee. So what do you want me to do? So when no data is found, this is what I want you to do, right? Maybe if no data is found, maybe send out an alert email saying that, hey, I could not find an employee with this, right? Then the reverse is the case. It's also true, right? Maybe you get too many rows. But maybe I was expecting that if I put employee ID 101 in the system, I should only get one employee, but for some reason I'm getting 10 employees back. That might be a bug, right? Then there's dup val on index. Dup val on index is if your procedure is trying to insert data into a table, and the table has a primary key, and you're trying to insert the same record, and it's causing a primary key violation, then you get this dup val on index. So it is useful, for example, like let's say you have a program that is logging information, right? And every time you log it, you save it with some unique number, and then you have a bug in your program, and you keep getting the same number that has already been reused. Then when you try to insert the log record, it should fail and tell you that, hey, that log ID you're using has already been assigned to somebody. So that's a failure. There are value errors, zero divide. I mean, these are when you're doing the mathematical operation and things are not working out. You have invalid cursor. If something is wrong with your cursor, you're trying to process, and then there's this not locked on. There's a whole list of them, and the more you write these, the more you find a need for them. Now, the nice thing is you can actually create your own custom exception. So typically, you may have some business rule that says, if some scenario happens, it's an exception. So then you can create one and save it. And anytime somebody was writing the program and that happens, they can call that exception, right? These are all useful for organizations because you don't want people sort of to reinvent the wheel. So if we've standardized the way in which we report errors and we've gone through the headache of it, then if your program has a scenario where an error happens, you just call that exception and it will take care of it, as opposed to you also writing your own rules as to how you handle errors. So if you ever want to create an exception on your own, there's the structure. You say declare and the exception name, right? In this case, they want to call the exception view does not exist, and it's going to be of the exception type. And very importantly, you say pragma exception init, and then you give it some unique code that you're going to use. You put some logic in here, and then you say exception when view does not exist, then null. Okay, that's your custom exception. Now, I'll take a pause here and try to get a sense of where folks are. Is PL/SQL very difficult for you guys, or is it very foreign, or at least does it at least now sound like you feel like, okay, you get a sense of where it's going?
I feel like I get a sense of where it's going, but it needs a lot of practice.
Yeah. I mean, it needs a lot of practice. I'm going to give you a couple of scenarios where you would practice them. I mean, some of these examples they give you are actually, I mean, even though they don't seem like very relevant, the structure is the same. You're going to find yourself doing a lot, and again, it's just a matter of getting actual assignments or projects to work on, right?
Right.
That will give you that opportunity to try your hands at it more and more and more. Emmanuel, sorry, you were saying something when Andy was also talking, so I couldn't hear you very well. What was it? Right, and I appreciate your honesty on that. I mean, it's this level of SQL knowledge, you need to tap into, you need to know some programming. So if in fact, it's funny, as we're going through this, I'm saying if you've not programmed before, well, this is your introduction to programming, right? When I say programming, it's actually talking about procedural programming, right? Programming where you're stepping through line by line and you're doing something. See, remember, when we're learning SQL, it says select from where, right? And there we actually talked about, I think it was Cyril who was saying, okay, so which part actually starts first? And I said, well, actually, first it actually figures out the source of the data, which is a from, and then it will join the data, and then it will then, after it's joined the data, it will then, if there's a group by, it will do it. Then before it actually selects the fields, and after it selects the fields, then it orders the result set. So it's not if you look at POs, if you look at SQL, it's not sequential, it's not step by step, right? If you say select field 1, field 2, field 3 from table 1, it's not going like select field, it's actually, it first goes to table 1, reads the data, then it says, okay, let me select field 1, field 2, field 3. It's sort of in that sequence. So in that sense, it's not procedural or sequential. When you talk of PL/SQL, you're actually talking about something that is done in a sequential manner, right? Which is what a lot of programming, when we say somebody's a programmer in the traditional sense, that's what you do. There's some process that you have in a business that somebody has written down a set of manual steps, and we follow it every day. So it very well could be that you go to work and the first thing is somebody creates a spreadsheet. Okay. After they've done, they email it to this person. After the person receives it, they open their spreadsheet, go to column D, and inspects it, and then create column E, which is equal to column D multiplied by some number. Once they are done, they give that spreadsheet to another person. I mean, that's actually how traditional, even today, you find some teams that are that inefficient and it's not automated, right? Sometimes for good reason, okay, because they are trying to do something new. Sometimes, yeah, you do find that, which is there's all these steps, right? Sequential steps that they are following to achieve a certain business process. Now, once that business process is standardized, as in they are very confident that they come in the morning within 2 hours, they can follow these 20 steps and get this job done. Then the next phase is, all right, we need to write a program to do this, right? Because number one, it's kind of pointless to have human beings actually do this all the time. What if two people don't show up to work that day? Then what's up? Then the whole thing gets held up, right? And with human intervention, somebody may move column C to column D and swap a few columns around, and everybody's screwed up, right? So you need to figure out a way to automate it. And so you tell us the rules, and as developers or as programmers, when we come in, we work with business analysts and project managers who have a sense of what these processes are. So you sit down with them, they tell you what they want, what they're doing, what's their current state. You sit down and come up with, okay, this is my plan to automate it, right? I'm going to store some data in some Oracle table, okay? And every day, somebody has to load that data. So in a lot of systems, what that means is maybe there's a website and people go in and put the data into the website, or there's some file that is coming from some other system through FTP, and the file comes in and it gets loaded into the table that you've created in Oracle or any database for that of your choice. So once the data is loaded in Oracle, let's say the person who is saying, oh, my job is I get this data and I go to column D, I inspect it, then I click column E. And column E is equal to column D, whatever value is in D1 multiplied by 1 point something. Whatever, if maybe column A is something, do this, some rule, right? Some rule that they have. So then you can then say, okay, this is what you're doing. I can write a SQL code. It will get the 4 rows, 4 columns of data. Select column A, column B, column C, column D. And then column E, which is now a function, is going to call some function you're going to write, and that function implements exactly what that new person is doing, right? And that's how this thing comes together, Emmanuel, which is functions and procedures and PL/SQL in general. They are there, or PL/SQL in general is there to help you do more automation, right? Maybe I'm going to use a final analogy, and I think Andy, you're also familiar with Tableau, correct?
A little bit, just a little bit.
Yeah, okay. So, I mean, Emmanuel is familiar with Tableau, and I want to use a Tableau example. So, in Tableau, he creates dashboards. So, in a dashboard, he gets data from different sources, and then he publishes them, right? So, Tableau has these procedures and functions already that you're using today, Emmanuel. So, I'll give you an example of one of them, which is when you deploy Tableau, right? When you push a dashboard, when you publish it, right? And then you have to do that data refresh, right? You schedule it, okay, refresh this data extract every 12 hours or so, right? Or every 8 hours. That's actually a procedure. Somebody's written, you deploy some code into production, and then behind the scenes, Tableau says, okay, when the person was deploying it, they gave me an instruction that every 12 hours, I should go and refresh the data apps and run the query, pull the data in, and create a DTD or whatever it is, and then the dashboard will reflect the most updated data. That is a procedure. There's a process that you have defined that every day at this time or 12 every 12 hours, I want you to refresh the data or pull data from something. That's just a process. How do you achieve that if you don't have a procedural language that will give you the logic to say, check what time is it versus the last time we actually did something, and if it's about 12 hours, then do something. You cannot do that within your SQL. Okay, you can only do that within a procedural language like PL/SQL or C Sharp or Java or Python or any. There's so many of such languages out there. Okay, that's why I'm saying that you need to know a scripting language, because that will make you stand out. In my own professional experience, I know that's one of my my biggest advantages I have over most of the other people I work with. And I know a lot of scripting languages, and every time you give me a project, it's like I can think of so many different ways of doing it, and it's always just a question of picking out which one is the faster way of doing it, right? And I can save myself a lot of time that way. But beyond that, the power of scripting or the power of automation is that they go hand in hand, right? When we started this, I said databases exist so that organizations can centralize all these different data sources they have, standardize them in such a way that it's easy to query and get results back. And these results, somebody can take actions on them, right? The process of getting the data, loading and storing them is one thing. Beyond storing the data, you need to now have things in place that will allow you to do the behind the scenes work. Okay. What they call like middle tier, which is a thing that kind of binds like the front end to the back end data, right? And there you always need a procedural language of some sort, right? So again, with a Tableau example, yes, you create your dashboard, which is a user interface, and you deploy it, and it has a TDE attached to it with some data. However, what is the process that's going to constantly refresh it, right? You said I went and I scheduled a refresh during the deployment. Well, yeah, you click some buttons and you specify some values, but that was behind the scenes creating or at least calling some program or code that would do that for you. And this is where PL/SQL comes in, right? So PL/SQL is very tightly integrated within Oracle database, and it has a very nice. I mean, so it really connects to Oracle and does. It's very fast. It's very fast. So yeah, I always say that the key is that think of it as if you have your data on one server, which is in Ohio, right? And then you have another server in Maryland. By the time you pull your data from Ohio and move it to Maryland to analyze, it will take some time, right? So and that's actually how things used to be. So what they had to do was to say, well, if I have my database in Ohio, why can't I have something which is also in Ohio so that I don't have to deal with traveling that time across the network, right, to move my data around? So Oracle hooked in a procedural language within itself so that the data doesn't have to just travel around the system. Okay. Yes, Emmanuel. Right, right. I mean, we're actually going to wrap up. We have just barely 10 minutes to go. Emmanuel says he has a question, Andy. I wanted to quickly touch on collections, which is the one area I didn't talk about before we end. But you know, just quickly, a collection is an order group of elements all of the same type, right? So typically, when you deal with data, um, and you're programming, you're writing a program, you have to figure out a way to store your data. Right? So in Excel, I always say Excel does it um, very seamlessly for us. You can have data in a column A, row 1 through 10. Right? It's like, you have a list of data, right? And it's in these rows. How you represent that within your programming language is what they call collections, right? So there's a bunch of collection types that are available. Um, here you can define your own collection as I have a collection, and each one represents the title, the author, and the year published. So these exist as one unit. Okay. Then you could also have a POSQL table type of collection. So here it says type book rec is record, and then you specify the columns. But here you actually say type book rec tab is table of the book rec type, okay, indexed by the binary integer. Okay. Now, why will you use collections is, for me, the biggest reason is that collections make your programming very fast. So using the right collection type can actually speed up your program a lot. In fact, sometimes I find myself like I had to update a table that had 165 million rows. And my boss was, what's the fastest way to do this? So I did some testing in the dev environment where I put like, I think 15 million rows or something. And the dev, I tried two approaches. One approach took 18 hours or whatever it was. I can't remember the exact. And then I said, okay, this is not acceptable because if I scale it times 10, that's like 180 hours, right? I cannot do it over a weekend. And I was constrained that the thing had to be done on one weekend. If I'm starting like say Saturday morning, you have to be able to finish it before Monday, Sunday midnight, right? Because you have clients in Asia that come on board after that time. So I had to think of a way of doing it. And the collections, I'd learned collections, and I used one approach that way, and it was very, very, very fast. So they are really good at speeding up your program. Oftentimes, you find out that when you're dealing with cursors, you would find that cursors and collections work hand in hand together for faster performance. Okay. So if you're interested, you can certainly read more about this stuff. What I've told Andy at the beginning is I'm gonna give to you guys one more session, and I'm hoping everybody sends in their payment before the next Saturday session. And what I would do is I would do my level best to demonstrate at least a function, a procedure, a package, a collection type, exception handling in our project, right? So I know Andy wanted me to give him something so the guys will present, right? And so I've kind of threaded throughout this, thinking we had in my mind what I can give you guys to kind of do as a store procedure. So, Andy, here you go, right? And then after this, Emmanuel, you can ask your question. You try to create a function, right? You know how we did this whole thing about for each employee, find their salary compared to their average in the department, right? Are you there?
Yeah. Yeah.
So I'm going to try to give you an example along those lines. So two things is I want you to create a procedure, and I want to create a function. So in the function example, I want you to create a function that if I give you the department ID, you can tell me the average salary.
Okay.
Okay. So then once you've created that, all right, then I want you to write a query that will use that function, right? To then say for each employee, compare the employee's salary to the average within their department.
The query again, please.
So for each employee, you show the employee ID, employee name, their department, their salary, and then their salary relative to the department, like a ratio, the
Okay.
department average.
Okay.
Right? So simply put, you have to create a function. I'm just trying to give you a guide, right? So you create a function, and you can have a function that its job is it will take the department ID, the person's department ID, and it'll quickly get you the average, and then it'll return the average to you. Now, you'd have to do something along these lines, sort of a combination of this and that. Okay, that's all I will tell you. And then
Okay.
once you have that function, that once the functions, let's say the function name is Andy, and then if Andy you put in parentheses the department ID, it will give you the average of that department ID as a number, right? And you can use it within your program.
Okay.
So, all right, I'll reserve the last 5 minutes. Emmanuel has a question that he thinks will benefit you as well. So, Emmanuel, go for it. Okay. What's the heading? Okay. What? Runtime. Okay. 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 Wait, is the runtime column you have? So you have a table with two columns, A and B, and three columns. And then column C is what? So column, okay, this is runtime A, okay, and then runtime, okay, okay, okay. So this piece of it is that Andy, I'll explain to you once I'm done, okay?
Oh, okay.
Um, yeah, okay, okay. But okay, so all right, just so Andy is not totally bored out of his mind here. So Emmanuel had some data in this structure. There's three columns:
Okay.
title, runtime A, and runtime. Right. I'm not sure why he calls it runtime A here, but for lack of right. And he says this is data. It's in this format. Yes, it's job A. It started. It started 11:50 p.m. and it ends at 1:30 a.m. There's job B. Started at the same time and ends at this. And he's interested in figuring out, is there a way to get some result that would say job A ran for an hour and 40 minutes and job B also ran for an hour and 40 minutes. Is that correct? In SQL. Now, I don't know why your data will be structured this way, but I presume it maybe you have some Tableau output that is in this format. Is you have a table that, right? So if Tableau is having an issue with it, then the first thing I'll draw your attention to is column A3 should at least have A in here, and column should have, okay. So this, if this is your structure, right, you effectively have to try to create a line for each of the two rows, right? Create one row out of the two rows, right? So because you need to, how would Oracle know that this is the start and end? And this is where functions come in very handy, right? If you have data that is sort of, it doesn't lend itself to easily write a SQL to do it, then you can think of it that if you had a function that, have a function that would take, you know, the job title, and then it would say something like runtime a value, for example. And if, let's say, you call that function, I call my function get, I usually call here because, you know, Excel is going to complain, but I could in theory call, you know, function, and I'll say a and give me start. And what it would do is, it would, behind the scenes, right, it says, it will run a query like select runtime from table where job title equal whatever input the user gave you, which in this case is A, and run time A is equal to start. Okay. So, I mean, this is right along the alley of what Andy wants, right? But you basically want a function. If you have a function, then no, what I'm saying to you is that if your data is in this format, right, and you're struggling to come up with a SQL to do it, then at that point you start thinking, okay, maybe I need to create a function, right? Now we just talked about how functions get created. And we said, okay, the general structure is create or replace function, get runtime or whatever. And it would take title as two. Okay, and then it will take runtime A, which is also two. Okay, and structurally it will be, you say, as and you'll see something like return to return some output, okay? And within that, you're gonna have something like insert. So you say begin, okay? And begin will run some query that will give you some output, right? Now, ultimately, you need to return that whatever the output is, okay? So the point I'm trying to say to you, Manuel, it's not a very simple problem when your data comes in this format. Now, but functions can help you deal with this situation, because if you have the function, then you could then in theory have a solution of your query that would say select get runtime, and it would say job title, and you give it runtime A, minus same structure, but it'll be runtime title, and it will say this would be start, and this would be end, something like that. Okay. So if let's say you had this, right, then you could say, well, from my table. Okay. Now here there might be dupes, so because of that, I'll just do distinct when it's all said and done. Okay. To clean up, it may not be a clean solution, but it will give you the numbers that you want. Now, that's one approach, is a create a function. The other approach is you would do what like you'll call like you pivot the data, right? So I mean, the structure of how to pivot data in Oracle or any SQL is very, very complicated. So yeah, I mean, I don't know what else that Imano. Yeah, yeah, and that's fine. No, I mean, you're right. I mean, it's listen, it's a reflection of two things. Sometimes, remember, if somebody may say, "Hey, why didn't you transform it yourself?" and you'd be like, "Well, I don't know how to transform it. You guys are the ETL guys. Why didn't you transform it for me?" And then may send you some code that will transform it for you, right? Because if you work in the ETL section, you have to be able to provide users that there, and it actually speaks to this is sort of, they call it columnar store of data, where sometimes they'll rather store data horizontally down versus they'll store it vertically down versus horizontally across. So instead of repeating um, having multiple columns, they'll rather have less columns and more rows, which in theory actually is much more efficient when you're storing data and you're querying it, but it's much more difficult to process as a developer, right? So if they can transform it for you, why not? But this lends itself, when data is in this format, it lends itself to using functions, right? Or you can do the transformation, right? And time is so far spent that I have to wrap up the session now. So as I promised, yeah, we'll do one more session on Saturday, and we'll use that to wrap up this session, this intermediate course. All right, guys.
All right. Thank you very much.
Yeah, you guys are very welcome, and good luck, and we'll see you on Saturday.
Okay.
All right.
All right.
Thank you.